This is Chapter 4, Goal 13, where you will be learning how to graph sine and cosine when there is a change in the period length. In Goal 12, you learned how to graph the parent functions for sine and cosine, and you learned how to graph sine and cosine when there was a change in the coefficient of sine and cosine, or a change in A. You learned that the absolute value of A represents the amplitude, and that amplitude, when you find the absolute value of A, your amplitude gives you your maximum and your minimum of the function, or the distance above and below the x-axis. What I'd like for you to do right now is to pause the screencast and in example A, graph y equals sine of x, and do the same in example B. Graph that function for one period. Remember, you also learned that the period for the parent function of sine and cosine is 2 pi radians long, which corresponds to 1 revolution around the circle. So please pause the screencast and sketch y equals sine in A and B. Okay, now that we've done that, let's take a look at example A, where I ask you to predict how the graph of y equals sine of 2x will compare with y equals sine of 1x. Take a moment and, with a pencil, sketch what you think y equals sine of 2x will look like compared to y equals sine of 1x. And use a pencil so that you can erase if you've made a mistake. Okay, here are some of the graphs that I sometimes see when I ask students to compare. Sometimes I see students change the amplitude and sketch something like this. You learned last time that the coefficient of sine and cosine affect the vertical max and the vertical min. And so because 2 is not the coefficient of the function sine, but 1 is the coefficient of sine, then this 2 should not affect the function vertically at all. So if that was your suggestion, let's see if you can rethink that. What about a horizontal transformation? Because 2 is inside the function of sine, it acts as if it's in parentheses. And you know that when there is a change inside parentheses that with x, then that change is horizontal. So did you stretch the function by a factor of 2? If it ends at 2x, did you multiply and get 4x? If it has an x-intercept at pi, did you multiply by 2 and move that x-intercept to 2 pi? Did you double the period? Well, if you did that, I'm afraid you would be incorrect. And let's talk about why. Recall that what you've learned about transformations this year, specifically about horizontal transformations, is that the operation you see in the function always shows itself in the graph in the inverse operation. So the inverse of multiplying by 2, as we see here, would be to divide all of our x coordinates by 2. So let's try that out. If I take my 5 key points, the x coordinate of 0, 0 is 0, and 0 divided by 2 is still 0. So that x coordinate will stay put. If I take the x coordinate that's halfway between 0 and pi, or pi over 2, and cut that in half, half of pi over 2 is pi over 4. So this would shrink to pi over 4. I want to briefly remind you how to divide a fraction in half. If I take pi over 2 and multiply it by 1/2, I will multiply numerator times numerator and denominator times denominator. So I've shrunk that in half. If I take my third key point, or my x coordinate of pi, and multiply it by half, it will shrink down to pi over 2. So here I've got 3 of my key points. The x-coordinate that is halfway between pi and 2 pi we know is 3 pi over 2. Half of 3 pi over 2 is 3 pi over 4. And then lastly, if we take 2 pi and cut it in half, that shrinks down to pi. So we see that my function, or our function, has shrunk significantly when x is being multiplied by 2. The original period of this function was 2 pi radians. So the period for y equals sine of x was 2 pi radians, but the period for y equals sine of 2x, the period is 1 pi radians, as you can see in the function. It starts at 0 radians and ends at 1 pi. Okay, I do want you to practice sketching this function in yellow again. If this function is 1 pi radians in length, then if we draw it again, that period should also be 1 pi radians in length. So if we draw it again, if we begin sketching at 1 pi, it should end at 2 pi. Remember our pattern for the graphs of sine. The x-intercepts are at the starting point, the ending point, and halfway. And from the starting point, we go to the maximum, back to the x-intercept, the minimum, and back to the x-intercept. And so I'm just following my pattern. If I ask you to sketch a third period, it should also be 1 pi radians in length, which means we would end at 3 pi. So we'd start at 0, maximum, back to the x-intercept, minimum, and back to the x-intercept. And we could repeat this pattern over and over and over. Let's take a look at example B. Predict how the graph of y equals sine half x will compare to y equals sine of 1x. Well, did you predict that the function would cut in half horizontally or that it would double in length horizontally? I hope that you said it would double in length. If the original period is 2 pi radians and we follow what we know about horizontal transformations, then instead of multiplying by a half, we should multiply by 2, and that should stretch horizontally. Let's see. 0 times 2 is 0. Pi over 2 times 0 is pi. Pi times 2 is 2 pi. 3 pi over 2 times 2 is 3 pi. And 2 pi times 2 is 4 pi. So this does stretch our function horizontally. So the period of the parent function, y equals sine of x, was 2 pi, but the period of our new transformed function is 4 pi. So how can we determine the period length without having to sketch the parent function and then multiply or divide by this coefficient of x? Let me see if you can figure that out. Look again. In example A, the parent function, where x had a coefficient of 1, has a period of 2 pi. So the coefficient of x was 1, and we call that coefficient of x b. So b was 1. And in example A, for y equals sine 2x, b was equal to 2, and the period was 1 pi. In our final example, the coefficient of x, or b, is 1/2, and our period was 4 pi. So in order to calculate the new period, if we divided by 2, we came up with a period of 1 pi. If we divided by 1/2, or keep it, switch it, flip it, multiply by 2, we came up with a period of 4. So your formula to calculate period of any function for sine and cosine is 2 pi divided by the absolute value of b. Please make sure that you commit this formula to memory. I want to finish up by looking at question C at the bottom. It says, compare the functions in A and B. What is the connection between the value for B and the period? Okay, so we've discussed that. The value for B, you divide the period by the value for B, and that will give you the new period. How will B affect the graph of cosine? And it should affect the graph of cosine in the exact same way as sine, because sine and cosine, the parent functions, both have a period of 2 pi. But there's one more thing that I want you to notice about how the value of b affects the function. If we look at example A, b was equal to 2, and the period repeated itself not once, but twice between 0 and 2 pi. Let me say that again. In example A, the coefficient of the angle, or the coefficient of x, was 2. The period repeated itself 2 times between 0 and 2 pi. In example B, the coefficient of x, or the value for b, was 1/2. And the function for sine showed up 1 time between 0 and 2 pi. So b will not only stretch or shrink your period length, but it will also tell you how many times your function will occur between 0 and 2 pi. Make sure that you also watch the Chapter 4 Goal 13 practice screencast. If you complete the notes for the Chapter 4 Goal 13 practice and turn those in class tomorrow, I will add a bonus point to your Goal 13 quiz. So make sure you watch it, but make sure you keep that to yourself so that everybody has a fair advantage for earning those bonus points. Thank you.